In today's lesson, we're going to look into more depth about the processes of the water cycle. This is for 1.B and the Earth Life Support System for the OCR A-level. Again, looking at the inputs and outputs of the water cycle and various processes involved. So this is what we might expect from our typical diagram about processes and flows in the water cycle. Remember, we're going to look at it today from the drainage basin kind of level, more of a localized level. So we're looking about and thinking about open systems here. Before we move on to kind of more complex stuff, when we think about a drainage basin, I just want to think and kind of make us understand that we talk about them as open systems. That means they have both inputs and outputs. And I've put this water butt here, which is being filled up from the gutter, just to show how similar they are. So this water butt here has inputs, and at the tap at the bottom it has outputs. And it's exactly the same if I look at my drainage basin. I'll have inputs, often in the form of precipitation, and then outputs, which in this example would be the stream flow from the river. So it's just about breaking down and thinking that we can apply that to most systems, but just showing how easy it can be just to kind of separate these ideas out. Now looking at those inputs and outputs, we can think about how water could be balanced in this system. And will it be balanced and change over time? And as I said before, in the inputs we would have precipitation. But in terms of outputs, we would not just have stream flow, but we'd also have other things which are going out of that system, out of that drainage basin, potentially into another drainage basin. So we would have evapotranspiration, which is a combination of evaporation from leaves and transpiration from leaves. As I mentioned before, stream flow, but also we would have changes in storage. So the storage, things like lakes, but also under the ground in terms of groundwater, whether they change over time. And so we get this water balance equation. The water balance equation is simply precipitation should be equal to the amount of evapotranspiration, stream flow, and any changes in storage. If those are both equal, then we have water balance. But often, because these are open systems, water balance isn't always going to be completely equal. We're going to have periods of surplus and periods of deficit, and I'm going to give an example of that now. So here's an example of a river, an area, and we're looking at it over several months across the whole year. And the blue line that I've just highlighted is showing the precipitation. That shows the amount of rain coming into this drainage basin and this river over time. And the red line I've just shown is showing the evaporation. So when we have precipitation being higher than the evapotranspiration, that means we've got more inputs than outputs. That means we're going to have a water surplus. So in some ways that can be shown in that there'll be lots of water in the river, and we could see that if we looked at a discharge chart, but it also could be, and that means all of the stores, the lakes and the groundwater would be full of water. However, later on in the year, as temperatures rise, and especially if we look to the UK in the June, July and August, the actual evaporation and transpiration is much higher than the precipitation. Therefore, we're going to get a deficit because more is leaving that area than is actually coming into it. After we have a period of water deficit, we get this moment where the stores change. So that water that was surplus and was plentiful in those groundwater and lake stores actually starts to kind of get used up. And so we therefore get it being recharged afterwards. When the precipitation starts to go higher than the evapotranspiration, we get what we call recharge. So again, in this period afterwards, we can see the blue line is above the red line, and therefore we're getting more inputs for the precipitation than the outputs. But because we've had that ground store depleted, it takes a while for it to recharge, fill up again, a bit like a water bottle being filled up, and then after that we can have surplus on top of that. So this shows you an example of the water balance working across a year in an actual location. I'm now going to talk a little bit more about the processes in depth, some definitions and the characteristics and things that change about them. So precipitation, it comes in many forms, but essentially it's water falling from the atmosphere, and it can either be come in the form of liquid or solid. We've got examples of hail on the top left, snow, and the most obvious one, which is rain. When we get a lot of rain, the kind of most obvious thing that you would have learned at GCSE is that most rain will eventually end up in streams and rivers, whether it's from kind of natural purposes or if it's from actual human systems that put it into there. So, however, but if we go to slightly different parts of the world, so if I go up into the mountains perhaps, or if I go to a higher latitude than we live in the UK, so if I go to Norway and Iceland, the precipitation there won't always fall as rain, it will often fall as snow. And that means there is an actual bit of a lag time. So there's when it falls and actually when it would end up in places like rivers, there would be a longer time. That's because it's staying on the ground for much longer, it's not melting, and often in places like Norway it would actually form and consolidate into ice in the glaciers, and therefore that would take a significantly longer time to get back into that river. We can see this in examples of discharge and river regime charts. It shows you here that it depends on what type of precipitation you're getting in the area and how that kind of will move around the rest of the system. As I said, the longer it's on the ground, the longer it takes before it gets into the river. In terms of, on both of these graphs here, this is a runoff from a river, and we can see that the runoff is quite low in these early months, and that's because the precipitation in both of these examples, a snowmelt and a glacier, is actually falling as snow in those early months, and then later on when it melts we get a sudden peak in the river because all that snow, as the temperatures go up in the kind of end of spring, early summer, when those temperatures goes up, they melt the ice and it all runs off and ends up into the rivers in that drainage basin. Therefore, it's important to see the type of precipitation and how that might affect other processes in the water cycle. We also need to think about other factors that might affect our water cycle. So the intensity of the precipitation. You see on the left here, this guy hasn't got much rain happening, but on the right, it's really intense, it's torrential rain. So if we have intensities of up to 50 millimeters an hour, that will fill up the ground because it will exceed the infiltration capacity. And you will therefore get surface runoff, otherwise known as overland flow. And in the worst case scenarios, you'll get flooding. Similarly, if we have duration, if we have a long period of rain, then that is a higher chance that the ground will fill up with water. That means we're going to get all our stores under the ground will be full up, and therefore it will cause surface runoff and overland flow, which again can lead to flooding. The last thing to kind of consider, we talk about scale and time a lot, that depending on the country or the region, you'll have some regions which will get a rainy season or a dry season. As we can see on this discharge chart, the peak rainfall seems to come in the kind of August period. This is an example of the monsoon season that you would get in India, but if we looked even at the UK, we would get much more rain in the winter months, so January, February, and December and November, than we would in the summer. So we don't have a rainy season, but we know that we will have peaks there, and that will obviously affect our flows and affect our stores in the water cycle system. Another really key process to know about is transpiration. As we see on the diagram here, water taken into the plant via the roots, it kind of travels around the plants and eventually leaves through the pores, through the stomata, in a process we call diffusion. That's where it goes from a high concentration to a lower concentration. So it goes from the plant, which is full of water, into the atmosphere, which has less water vapor in it. And it's going through this little gap called the stomata in the leaf Things that would affect transpiration, so if I increase the temperature, that means transpiration is going to happen at a quicker rate. And the same, in windier conditions, transpiration will happen at a faster rate. So we can have factors that will alter our rates of transpiration. Transpiration, again, is subject to seasonal change. You can see the differences in these pictures here. The trees at the top have got lots of leaves and they have lost their leaves in the winter. We often see that in the UK, and because we have a drier, colder climate here in the winter. So plants get rid of their leaves, and these are called deciduous trees. And the reason they do this is because of transpiration. They want to make sure that they can retain water throughout the winter, and so because they lose so much through the leaves, if they get rid of their leaves, it stops it being lost through that process of transpiration. So transpiration rates aren't continuous. They will change depending on the season, especially in areas like the UK where we have deciduous trees. Condensation, another kind of term you'll have come across before, but it's basically when any sort of water vapour changes into liquid. And when we think about it in a kind of water cycle, we need to know this word dew point. It's the temperature at which air is cooled, and that's where it goes from being that vapour into a liquid form. Here's an example of that actually happening. We've got a parcel of air that's warmed by the sun's heat, so that's warmed up the ground, which has warmed up the air above it. We know about warm air as it rises, and as it rises, it starts to get cooler. And when we get to this point, this is where this air has cooled enough that any water vapour in it has suddenly started to turn to liquid. And that dew point is that temperature at which that happens. So it's where the rising air becomes completely saturated with the water vapour, loads of water vapour droplets in it, lots of moisture, and it condenses into a cloud. In terms of the actual types of clouds that we're going to get, some of these you recognise, some of you won't. Cumuliform clouds, you can see here it's got a very flat base, but it extends up vertically. So you'll have seen cumulonimbus clouds that we talked about in hazards at GCSE. This is again where the air that's above the ground is heated. So the ground warms up, that air is heated and then rises, and then as it cools, it turns into these big fluffy clouds, and that process is convection, which we're going to cover a little bit more in another video. On this right-hand picture, we've got stratiform, so stratus clouds, otherwise known as layer clouds. That's formed slightly differently. That's when that air, that parcel of air, actually moves in a horizontal fashion over a cooler surface. So it might go from being over the land to a cooler ocean, and as it does that, it actually forms these kind of layer clouds. It's a process, that process of going horizontally over a cooler surface and condensing into clouds is what we call evection. And the last one, which doesn't have as big an impact on the water cycle, is cirrus clouds. This is where they haven't got as much water vapour in them because it's drier air, but as that goes up, it gets changed into ice crystals because of the higher altitude. Again, this one's not so important because it doesn't have as big an impact on the water cycle, because it doesn't have very high precipitation rates, and so doesn't add much input into our system. Last thing to really note is we get fog, which is clouds basically formed at a lower level. This is important is because this is where we get condensation happening low down, and because of that, that means the water that's actually formed in that condensation period is being spread and deposited onto the land and any vegetation, as we can see here. So that does have an impact on our water cycle. And again, this is a process often caused by advection. So where horizontally an air moves over a cooler surface, and when that cooler surface kind of creates the dew point for the air, that means it causes condensation.